Okay, let's use this perimeter formula that we just derived to calculate the perimeter of a regular 11-gon. Before we do that, we want to get a very rough estimate of what we should expect our answer to be to see if we're doing it correctly. And for a polygon with a lot of sides, the circumference of the circle is actually a fairly good estimate. And it's by inscribing polygons in a circle that we were actually able to compute pi for the first time. So hopefully we remember that the circumference of a circle is 2 pi r. Right, so twice the radius times pi, or the diameter times pi. And here, if our radius is 12, we're looking at 2 pi times 12, or 24 pi. Now we could approximate pi as 3 and say that our circumference is about 24 times 3, which is 72, if we want to be really, really loose about it. Or we could plug 24 pi into our calculator and get a more precise answer, 75.4, say. Okay, so 72 is a pretty good approximation. And we should actually expect our perimeter of our regular 11-gon to be a little bit smaller than the circumference of the circle, since it is inscribed inside the circle. So that 72 that we got is actually probably a pretty good estimate. All right, so let's see how this thing is going to work. Well, if we have an 11-gon, our n is going to be 11. If our radius is 12, we're going to plug 12 in for r. So then our perimeter, using our formula, is, remember, it's 2nr sine of 180 over n, right? So we're looking at 2 times 11 times 12 times the sine of 180 over 11. And notice we're using degrees here for our angle, not radians. So I'm actually just going to take this entire expression and plug it into my calculator, making sure that I am in degree mode. So 2 times 11 times 12 times the sine of 180 divided by 11. I'm going to make sure I close my parentheses. And I get that this is about 74.4. And we didn't have any units, but whatever those units are, that's what our perimeter would be.